Hello and welcome to week 1, Introduction of the ABAP RESTful Application Programming Model. In the second unit, we will talk about the architectural overview. RAP has basically 3 layers. The CDS entities and business object are defined in the data modeling and behavior layer. We discussed that we want to create role-specific applications in the first unit. So therefore, based on our data model and the business functionality contained in our business object can be projected role-specifically. These business object projections, or CDS projections, can then be exposed via a service definition. So the service definition is a bracket around this content and defines the scope to be exposed in a service binding. The service binding defines the protocol and also the use case, web APIs, for example, or Fiori UIs. But what exactly is now a business object? Business object has basically 3 parts. The first part is a data model. The CDS entity defines the root, and via compositions we can navigate to the child nodes. So a business object, like the business partner, the product, or the sales order with all the child nodes, is basically a composition tree. And besides this data model, we can now attach behavior. And this makes now the CDS artifacts to a business object, extending it via a behavior definition. We can specify default operations or standard operations like create, read, update, and delete, and also specific operations like actions and functions. Concurrency handling is done via logs and e-tags. Authorizations, feature control, and draft are also very important features. And now the third part of the business object is defined by the runtime or the implementation. Independent, whether we are using or reusing existing application code or starting from the scratch, a business object has also 3 important parts. The first part is the interaction phase. When the end user presses the edit button in an application until he or she presses the save button, all the data which was entered in the meantime is written to a transactional buffer. The transactional buffer is then in the save sequence written to the database. Now, storing all the changes in a transactional buffer, of course, does not work for a stateless application. And as we discussed in the first unit, stateless communication is really crucial for our cloud environment. So the draft fills now the gap between the stateless communication required for the cloud environment and the nature of a stateful application, because somewhere the changes need to be stored. The draft persists now the transactional buffer or the changes written to the transactional buffer on the database. So the draft becomes an own resource, which is also addressable via OData. And therefore, the draft fills the gap. We do not have ABAP sessions between 2 calls. We just have one ABAP session while we execute the changes. Of course, the changes within a draft are also stored in a transactional buffer before they are persisted. And now the draft also requires, of course, logs. Therefore, we extended the enqueue server functionality via durable logs. The durable logs are no longer bound to an ABAP session, but are bound to the draft itself, the draft instance on the database. That means in detail that the interaction phase contains all the modify calls, the read calls, and the logs. Changes are written to the transactional buffer, and the save sequence for the active data only, because for the draft we do not have a save sequence. For the active data, we have finalize, check before save, adjust numbers, and save. In the finalize, all business objects can do the latest changes. Why? Because only if no changes can be applied anymore, each and every business object involved in one transaction or one application can decide in the check before save if the current status is consistent or not. And if every business object agrees that the state is currently consistent, then we can trigger the adjust numbers to draw the numbers for legal reasons very late, and can also persist the changes to via the update task function model. Adjust numbers is of course an optional step. And now if you have a lot of legacy code, you can make use of a business object with an unmanaged runtime. That means we do not manage the runtime completely, but you own the transaction buffer. You implement create, read, update, delete, and the actions and functions completely, because you have your business logic already available. It was already there before you thought about RAP and Fiori apps maybe. It was done because you decoupled your coding from DynPro modules when you wanted also to create BAPIs or to integrate your logic into a WebDynPro ABAP application. We define adapters as a one-time sustainable investment, and we take care for further integrations into Gateway, OData v2, OData v4, or even other protocols. But we also discussed that besides the crucial point of integrating existing logic, it is also very important that we can create very fast new applications from the scratch, so that web can take over technical implementation tasks and the application developer can focus more on the business logic itself. Therefore, we offer also the implementation type managed. In managed, the standard operations work out of the box. Without a single line of code, we can have a full-fledged user interface supporting create, read, update, delete with all the draft functionality. And now the application developer can attach business logic like determinations and validations and specific logic for feature control and authorizations. Of course, here we also do support breakouts. For example, you can reuse existing log objects or existing update task function modules. So you are free to choose where we should take over your technical implementation tasks and where you need the freedom to implement what you want to do by yourself. So how does the development flow look like? First of all, we start with CDS, the first part of a business object. And in case of a business object, we can extend the data model via the behavior definition and implement it via ABAP code. And now it is completely based on the implementation type, whether we implement create, read, update, delete, or if we implement determinations and validations. A log object can be integrated if it is existent, or we make use of the generic managed log object. This can also, of course, be included in the authority object, which can be accessed via a DCL in CDS. Unit testing is also possible for our very small units in the business object. And also integration tests can be written based on our business object via the entity manipulation language. EML is a standardized ABAP built-in and documented API to access any kind of business object from outside. So now how can I create business services on top? That means role-specific applications, for example. So first of all, what is a business service? Business service is basically defined via service definition. As I said, it defines the brackets around the entities to be exposed. The projection defines which elements needs to be exposed via CDS. And the behavior definition defines which behavior should be exposed. As I said, we have the business object, which can be reused in multiple applications. We define a projection on top, which scope is really relevant, and then the service definition defines which different parts of the business object and which, if even multiple business objects are involved, which of them are then exposed to a service binding, which is then the second part. The service binding defines whether it is OData v2 or v4 and which use case to be supported. In case of web APIs, release, versioning, and deprecation is really important. Because if I release a web API, then we can offer compatibility checks that this web API is compatible for the future. But if we want to have a planned incompatible change, we also need some kind of versioning so that the new version includes the innovation and the old not. And if we have multiple versions, then maybe some point in time we also want to deprecate an older version. The tool support is also very important, and because if we know the scenario defining the service binding, we can distinguish the tooling. So for UI, we can offer a Fiori Elements preview. For Web API, a Swagger UI preview might be useful. Now it's in the nature of a Fiori UI or Web API OData service that not all features are required, and we want to optimize the OData service towards the specific scenario. Also, therefore, it's really important that we understand for which scenario the OData service is used. UI annotations are only relevant for UI, same to value help and dynamic feature control and draft. On the other hand, web APIs require more complex requests, batch requests, maybe also containing content IDs, where I define a new document or new instance, and afterwards I want to execute operations based on this instance within one $batch request. This is content ID referencing. Release, versioning, and deprecation might be also more relevant for web APIs. And the development flow is now extended by creating the projection and then, as I said, defining the service definition. In the service binding, we can see then the preview. What's also very important is that we assign the roles for a specific service, otherwise we can't execute it. Testing is now also supported by the gateway local client proxy. We can execute local unit tests without HTTP. This is really useful because we can make use of all the different test double frameworks which are available, because this is only doable if we have it to be executed in one ABAP session and not via HTTP. So this is a good one. In this session you learned about the architecture of the RESTful ABAP application programming model and the vital parts. You learned about business objects and business services and how this all fits together. You learned about the unmanaged and managed business objects and why we offer both of them. One is for the legacy code and one is more for taking over technical implementation tasks to improve the development efficiency. And you saw the development flow for our web applications. And guess what? Exactly this development flow is also supported by our ADT tool. It will always be happy to navigate from one step to the next by a right click on the context menu. In the next unit, you will learn about the involved technologies. See you there.